जी, yesterday we were talking about nomenclature, so हमने nomenclature study किया था और उसके अलावा हमने सिर्फ अभी तक discussion की थी ऐसे compounds की जो straight lines में होते हैं जिनके ऊपर कोई branches नहीं होती हैं. Actually अभी तक हमने branches को भी define नहीं किया है. That's yet to be defined. And the straighter structures are easier to name because we take the prefix, we take the suffix, we combine them together, and there you go, you have an easy name. These names are simpler, one word dependent, and they have no numbers in them, and they're straightforward structures with no complications in them as well. Okay. So what we are going to do today is that we're going to step up. We're going to go with structures that have branches, a little bit complicated structures, how to draw the structures, how to conclude their name from them, or vice versa. So that's what we are going to do today. So once again, like yesterday, I'm going to switch in between the Word document and the drawing files. So please go with it patiently. If you don't understand anything at any point, let me know. Just give me a minute to change the sharing. So what I'm going to do is that I'm going to quickly move to the document where we are supposed to have the structures drawn. And we're going to move to nomenclature of alkanes that we can work it out. Let's revise a little bit. Nomenclature of alkanes, the prefixes in simple alkanes for the parent chains, the basic chains we have drawn so far. Meth for 1 carbon atom, eth for 2, prof for 3, but for 4, pent for 5, hex for 6, hept for 7, oct for 8, non for 9, and dec for 10. So far, if you don't get the impression of this thing that you're supposed to memorize it as soon as possible, please take the impression, go ahead, memorize them if possible, cram them for their names so that you can get started quickly on this. Okay? The suffixes for alkanes is ane, alkenes is ene, alkynes is yne, alcohols are ol at the end of the name, carboxylic acid oic acid, and esters oa. The prefixes and alkanes for the side chains or the branches, what we are going to do today is mono for 1, di for 2, tri for 3, tetra for 4, so on and so forth. We were discussing the rules yesterday. The first rule was to locate the straight, longest direct carbon chain, and this would be the parent chain of the molecule. Number 2, as per the number of carbon atoms in the structure, take the prefix and combine it with the suffix. The structure type of bonding shows you, and you get the name. Okay? Suffix actually shows the structure or the type of bonding. Okay? So you get the name. Moving on, today we're going to go with the third point. For branch chain structures, the carbon atoms are numbered, and the numbering may start from either side, which means you may start numbering from left or from right or from top or from bottom. You can start it from any side, but there is a rule to it. But the carbon atom connected to the branch slash functional group should get the lowest possible number from that numbering sequence. We can start a numbering from either side. आप numbering किसी भी side से शुरू कर दे सकते हैं. जब हम कोई structure बनाएंगे, carbon atoms को number करेंगे 1, 2, 3, 4, 5. हम सिर्फ parent chain को number करते हैं. ठीक है? Let's write atoms over here and let's specify that we tend to go with the parent chain. Okay? And the functional group or the branch, the carbon which is connected to the branch or the functional group should sorry, The carbon atom connected to the branch or the functional group should get the lowest possible number from that sequence. We're still skipping functional group for now. We'll discuss that later. So what we are going to do is that we're going to define the branch. Okay, I've been using the word from yesterday, and this word might be confusing a little bit. So what I'm going to do is that I'm going to draw a couple of structures. First of all, I'm going to show you what a branch is, and then we're going to understand this point number 3. So let's get started. Just a minute. All right. Like yesterday, we were discussing the structures. And okay, let's start asking questions. Let's start from Zaim. Zaim, were you present yesterday, first of all?
Yes, sir.
Okay, so if you understand it from yesterday, I hope you can name this compound. You can look it up from the book, I'm fine by that. With 3 carbon atoms, with a straight structure. The page I was just at. I think that's page number 256. On the top of the page, we have the diagram for the structure, which consists of only 3 carbon atoms and 8 hydrogen atoms.
Sir, propane.
Propane, right. Prop actually is a prefix that is used for 3 carbon atoms, as you can see in this structure, and ane is used when they are singly bond. Once again, that is also visible in this structure, right? So this is propane. Are we all clear? Anybody having any questions? All right.
और इसमें 3 कार्बन एटम्स है क्या? तो हाइड्रोजन है लग रहा है.
Sorry?
इसमें क्या 3 कार्बन एटम्स हैं कि तो हाइड्रोजन के आगे है ना नंबर?
एक सेकंड, इसे थोड़ा सा बड़ा कर लेते हैं. जी. Can you see the 3 carbon atoms?
Yes, sir.
So 3 carbon atoms should have a prefix prop, right?
Yes, sir.
Let's calculate the number of hydrogen atoms. How many are they? 3 plus 2 plus 3. 8. 8. So if C is equal to 3 and H is equal to 8, does that go with the general formula of alkanes CnH2n plus 2? Means 3 multiplied by 2 is equal to 6. Add 2 to it, that would become 8. So if carbon number are 3, the hydrogen number are supposed to be 8 according to the general formula of alkanes. So this is an alkane, and for alkane, the suffix is ane. So prop is the prefix, ane is the suffix, hence the name propane. Does that answer your question?
Yes, sir.
Good. Now, there are multiple ways to look at them, okay, to treat them, to come up with their name. One is to go through the general formula that I just explained. Another one is to go with the structure and simply count the number of atoms. Once again, you can double check that with the help of the general formula, or you can simply come up the name according to the structure, the number of carbon atoms present, and the bonding. Right? Are we all clear?
Yes, sir.
Good, good. If anybody is still confused, let me know, because you're supposed to be clear at this point. अगर फिर भी कोई कंफ्यूजन है, अभी भी समझ नहीं आया, तो फ्रैंकली बता दें बेटा, क्योंकि ये बहुत इंपॉर्टेंट है. आगे पूरा का पूरा ऑर्गेनिक का पोर्शन 10 और 11 चैप्टर नेमिंग से भरे हुए हैं. अगर अभी भी किसी को समझ नहीं आता कि हमने ये इतना सा स्ट्रक्चर बना के इतने आराम से उसका नेम प्रोपेन कैसे दे दिया, तो मुझे बताएं ताकि मैं उसे फर्दर क्लैरिफाई कर सकूं. इन दैट केस मैं ये करूंगा कि मैं इसे ज़बानी नहीं बताऊंगा. हम अपने वर्ड डॉक्यूमेंट पे वापस जाएंगे और मैं स्टेप बाय स्टेप वहां से नेम्स को एनोटेट करके समझाऊंगा. अगर किसी को नहीं समझ में आया, अभी बताएं. All right. So let's clarify कि समझ आ गया है, ठीक है? Okay, what I'm going to do, अब आपके सामने एक simple सा structure नजर आ रहा है जिसमें 3 carbon atoms थे और मैं बार-बार ये कह रहा हूँ कि इसका नाम हमने propane रखा, prop because इसमें 3 carbon atoms हैं, ठीक है? So what I'm going to do is that I'm going to ask a couple of questions. Shahzeb is saying he's confused. हाँ, Shahzeb, ऐसा करते हैं, थोड़ी सी practice और करते हैं, and I want to make sure that you are completely clear about the concept, ठीक है? By the way, मुझे आपके क्वेश्चन पे अभी भी डाउट हो रहा था कि वो प्रॉपर्ली आंसर हुआ या नहीं हुआ, बट लेट्स जस्ट क्लैरिफाई, ठीक है ना, फॉर द सेक ऑफ कंप्लीट अंडरस्टैंडिंग. शाज़ेब, अगर इस स्ट्रक्चर में जो मैंने अभी ड्रॉ किया और इसमें 3 कार्बन एटम्स हैं, उसमें 3 ना होते, 4 कार्बन एटम्स होते इसी तरह एक स्ट्रेट लाइन में, तो आप उसे क्या नेम देते? प्रीफिक्सेस आपके सामने ओपन है.
बट
नहीं, पूरा नाम. But is only the prefix. By the way, it's but, it's not but. ठीक है? Okay, this is but. It's not but it's something entirely different. ठीक है ना? But it's only the prefix. You are also supposed to combine the suffix. Prefix is only the first part of the name. In order to get the complete name, you're supposed to take the prefix, join it with the suffix, and hence you get the complete name. So but is the prefix. What would be the suffix? Was the structure singly bonded? Is the structure singly bonded? Let's take a look at the structure. Sorry, that's not the window. Let's take a look at the structure. Do you see single bonds in between them?
डबल नहीं, सिंगल
Come on, these are single lines. Double bond और तरह से show होता है. Okay, let me convert this line into a double bond. This is a double bond. ठीक है? इस तरह से double bond show होते हैं. Let me convert this one into a double bond either. Also, okay, these are double bonds. Double bonds are shown with 2 lines. Let me convert it into a triple bond. This is a triple bond, right? So
yes sir.
Actually we were talking about single bonds. So मैं इसे दोबारा convert करता हूँ single bonds में as to answer the question, the whole thing. Now, are these single bonds?
Yes sir.
Yes, right? And if they are single bonds, what are they supposed to be called? Alkanes. And the suffix for alkane is, what is the suffix over here? Let me highlight
Ane.
that for you. Ane. So the prefix was but, the suffix is ane, the whole name would be
Butane.
butane. And there you go. You have butane right over here. 1, 2, 3, 4 straight carbon atoms and all the hydrogen surrounding them. It's just that you might are getting confused with this structure and this way of writing. So what we do, what we try over here is that I'm not expanding all the carbon atoms into separate structures. Okay? That would make it too big and the structure would be difficult to draw. In case of drawing softwares, what we do is that we take all the hydrogen atoms, combine them into one place and write that with this carbon. For example, let's go back to the book. Now, take a look at this carbon, the first carbon. Let me use an annotator. Let's use a spotlight. Now, according to the red spotlight, this carbon atom has how many hydrogens directly connected? Number 1 on the top, second on the left-hand side, third on the bottom. So it has how many hydrogens? 3. So what we are doing over here is that we are writing these 3 hydrogen atoms as H3 instead of drawing them separately. Are we all clear? ठीक है?
Yes sir. एक सवाल है.
जी बिल्कुल.
जो बीच में है, जो CH2 वाला है, जिसके साथ 2 है, इसमें एक है जो वो डायग्राम में था, उसके अंदर ज्यादा थे ऐसे CH2 वाले.
देख लेते हैं, वापस जाते हैं. इस डायग्राम की बात हो रही है?
जी.
Okay, take a look. Just central carbons होते हैं, they only have hydrogen on top of them and at the bottom. So every carbon has 2 hydrogens, either this one or this one. Are we clear?
तो ये ज्यादा भी हो सकते हैं इससे, जितने भी हो
Beta,
बीच में.
don't. Acha, okay, I was assuming that you still remember the basics of covalent bonding from 3rd chapter. Let me clarify. Let me revise. In 3rd chapter, we said that specific atoms can go to a maximum of specific number of covalent bonds. For example, hydrogen cannot make more than 1 covalent bond. And that is also true for fluorine, chlorine, bromine, and iodine. I mean all the halogens. They can only share one electron and hence can only make one covalent bond. Oxygen and sulfur can make 2 covalent bonds each. Nitrogen and phosphorus can make 3 covalent bonds each. However, when it comes to carbon, it can only make 4 covalent bonds. And that's how they are balanced. Clear? So take a look at this structure over here. As I said, one hydrogen is only making one single bond. This hydrogen is only making one single bond. This one is making one. This one is making one. Take a look at all the hydrogens. They're only making one single bond. And that's about it. Hydrogen is incapable of making any more bonds. Why? It has only one electron. So of course it's going to share only that one electron. It doesn't have any more than one electrons. How would he share? Right? So hydrogen is limited to one covalent bond. Now, talking about carbon, every carbon can make a maximum of 4 covalent bonds. So take a look at this carbon. One at top, one on the right hand side, one on the left hand side, one at the bottom. So this carbon is making 4 covalent bonds and getting itself stable. So is this carbon 1, 2, 3, 4. So is this carbon 1, 2, 3, 4. So the number of covalent bonds are specific for specific nonmetals. Okay? But as I was assuming that you would know that from chapter number 3, covalent bonding. So as we have forgot that, so what I'm going to do is that I'm going to write the whole thing over here, and you are supposed to copy that on your books. Number of maximum covalent, okay, let's write it, single covalent bonds an element can make. Okay, and for that we have H, F, Cl, Br, and I. These are equal to 1. O, comma S, they are equal to 2. Then comes N and P, phosphorus and nitrogen, they are equal to 3 each. And lastly, carbon and silicon, they can actually make 4. So that's what we are going to do. Whenever we are about to draw a structure, we're going to make sure that we do not go over this limit or go under the limit. We'll stick to this numbering. Why? Because at this numbering, their octet, I mean the outermost shell with 8 electrons is complete. As we studied back in 3rd chapter, the octet rule, the rule for having 8 electrons in their outermost shell. That was the end of chapter number 2, and we confirmed that thing during the bonding in chapter number 3. So I was assuming that you would remember that from chapter number 2 or from chapter number 3. So we have also revised that. Is your question answered or not yet? Because your question has many directions. So I want to make sure that I answer each and every single direction. So if there's any more directions that haven't been yet answered or you're still confused, please go ahead and ask. Don't be shy. Okay?
हो गया.
Okay. No, so I have clarified many things over here. Let's revise. And I'm doing this with the whole class, not just with Shahzeb, because the question was multi-directional and it was a very good question, by the way. So let's clarify all the directions. First thing, you're supposed to remember and memorize the number of single covalent bonds an element can make. Now, this is 1, for these are 2, for these are 3, and for these are 4. If instead it's not making 4 single covalent bonds, it can make 2 double covalent bonds, and still it would be the same thing. All right? It doesn't mean it can make 4 double covalent bonds. No. For double covalent bonds, of course, this capacity would be halved. So having the capacity, that would be 4 divided by 2 is equal to 2, which means it can only go with 2 double bonds. However, to understand this thing without any structure drawn in front of you or without any imagination is difficult. As we're talking about double bonds, so I'm going to clarify that in alkenes up next, not now. Okay? So as far as this structure is concerned, the second point is that this form of structure is the complete open structure in which every single bond is drawn. However, when I'm converting this structure into, just a second, into this one, ठीक, I'm not going with that rule. Drawing all the hydrogen bonds separately is not the case over here. So let me clarify the different types of structural formula over here. We've studied only one type of structural formula, and that was this one, this expanded one. This is known as expanded structural formula. You may write it over here. This is known as expanded structural formula. How do we define it? In expanded structural formula, all CH bonds, mean carbon-hydrogen bonds, are drawn and are shown with single lines. However, if we go with this formula, and this is the type which is known as condensed structural formula, condensed, C-O-N-D-E-N-S-E-D, condensed structural formula. In this case, what we do is that we do not draw carbon-hydrogen bonds. Take a look, there are no carbon-hydrogen bonds shown over here with single lines. Hence, the entire structure is shortened, is condensed, is written in a shrinked form. However, we do not use the word shortened formulas or shrinked formulas. However, the actual chemical term is condensed structural formula. Okay? So the number of maximum single covalent bonds an element can make, what are the types of structural formula, how are we going to sum that up? Now, third step is how are we going to sum it up? Take a look. Every carbon has specific number of hydrogen atoms. This one, this one, this one, this one. For the first one, it has 3 hydrogen atoms on it. Top, bottom, left side. So it is noted over here as CH3, right? So moving on, the central hydrogen atoms, this one and this one, both have 2 hydrogen atoms on them. Carbon atom has a hydrogen atom on top and at bottom. Carbon atom has a hydrogen atom on top and at bottom. So this one is CH2 and CH2. So of course they would become, let's change the structure a little. हम इस structure को सही कर लेते हैं दोबारा. एक second. And let's come up with, yeah, okay, sorry. Oh, come on. Now, that's correct. Now, this one is CH2 and CH2. And coming to the last carbon atom, take a look at the last carbon atom. It has 1 on top, 1 at bottom, 1 on the right-hand side. So CH3. So this one's CH3. Clear? That's how we convert the structures into the expanded structural formula into a condensed structural formula. And taking a look at this, there is one more thing that needs to be settled or clarified over here. The carbon at the corners contain 3 hydrogen atoms or more hydrogen atoms than the carbon in the centers. The carbon in the centers have less number of hydrogen atoms than the carbon at the corners. Now, the corner carbon atom is a childish name. I'm using the word phrase so that you would understand the carbon atom is present at the corner. ये एक side पे present है, ये कोने पे present है. ये compound का एक कोना है, ये compound का दूसरा कोना है. ठीक है? So, oh come on. Can you hear me, class?
Yes, sir.
Yes, sir.
Thank God.
Yes.
I'm consistently getting a notification that the system is unstable. Actually, the internet connection changed from 1.1 ISP to another. Okay. So moving on, that is these carbon atoms, which I am calling the corner carbon atoms. Please mark them on your book. Over here, this one and this one are known as terminal carbon atoms. Corner carbon atom is a childish name. The actual chemical term is terminal, T-E-R-M-I-N-A-L, terminal. Terminal means where the point ends, where the thing ends. So the structure ends at this carbon and this carbon. So they both are terminal carbon atoms. However, the inside ones, the inside carbon atoms are known as central carbon atoms. So these two are central carbon atoms. These two would be central carbon atoms, and these two, the one on the extreme right-hand side and the one on the extreme left-hand side, will be known as terminal carbon atoms.
उससे इथेन में सेंट्रल होंगे या कोई टर्मिनल?
दोनों टर्मिनल है, दोनों टर्मिनल है. इथेन की खास बात यह है कि इसमें कोई सेंट्रल कार्बन एटम नहीं है. ठीक है. प्रोपेन की खास बात ये है कि इसमें टर्मिनल तो हैं लेकिन सेंट्रल सिर्फ एक है. मूविंग ऑन, ब्यूटेन, पेंटेन, हेक्सेन, the central carbon atoms, the number of central carbon atoms increase. There are 2 central carbon atoms in butane, 3 in pentane, and 4 in hexane. Even in pentane, this carbon atom which is present in the exact center, that's how we name it. The carbon atom present in the exact center, not the central carbon atom. That's how we tend to talk. And that's simple English. I'm not talking in some gibberish or some other language. That's simple English. Terminal carbon atom, central carbon atoms, and the exact center of the compound. Right? In the same way, not just the carbon atoms, we can also name the hydrogen atoms in the same way. These hydrogen atoms, these 3 and these 3, these 6 hydrogen atoms are terminal hydrogens. While this one, this one, this one, and this one, these 4 hydrogen atoms are central hydrogen atoms. Do you get the point? So that's how we name them. The structures have many things to learn. ठीक है? और ये मैं step by step सिखाई नहीं इसलिए मैंने सारे structures एक साथ नहीं सिखाए. Why? Because if I throw all the information on one single day in one single lecture, it's sometimes very difficult to absorb, and students tend to forget. So एक दिन मैंने आपको simple structure सिखाए, फिर मैंने आपको उन structures के prefixes, suffixes सिखाए, फिर अब एक ऐसा दिन आ रहा है जिसमें मैं आपको terminals और centers सिखा रहा हूँ. फिर हम nomenclature जो होता है वो step by step चलता है. That's why nomenclature sometimes take 3 days, 4 days, or with a poor class it might take 7 days. But I don't mind. Some classes learn slow, they still act better in exams. Some classes learn fast, they may not act better in exams so much. Okay? So it completely depends upon your result, not the pace. Okay? So that's not the discussion over here. We have gone astray a little bit, but coming back to the point, do we understand all the directions of the question? How to name the carbon atoms, how many carbon atoms are there, how to name the hydrogen atoms, how to put them, what 2 kinds of structural formulae are there, what is expanded structural formula, what is condensed structural formula, and how many number of single covalent bonds or covalent bonds, maximum covalent bonds an element can make, and specifically if these elements are non-metals, the non-metals that we commonly discuss. These were all the directions of this question. Do we all understand this?
Yes, sir.
Good.
Yes, sir.
शादी परेशान हो गया तो इतना बड़ा सारा क्वेश्चन तो मैंने भी नहीं पूछा था. सर ने क्या से क्या बना दिया, 20 मिनट लगा दिए क्वेश्चन समझाने में. But Shazib, are you clear? You can say yes or no frankly. ठीक है? Clearer than before?
Yes, sir.
Good, good. If anybody is still not clear or they tend to forget it tomorrow or day after tomorrow because these बहुत simple छोटे points थे. वैसे तो आप ये क्या करेंगे बुक पे जरूर नोट कर लिया करें, बट अगर कोई चीज रह जाए तो नेक्स्ट डेज में जरूर पूछा करें. अच्छा ज़ैनब बेटा, आई एम ऑलरेडी शेयरिंग. ओके, आई डू दैट. ज़ैनब अपने क्वेश्चन का आंसर मुझे लेक्चर एंड पर याद कराएं ताकि फिर मैं वो स्पेसिफाई कर सकूं, बल्कि लेक्चर का एंड आ गया. अच्छा ज़ैनब बेटा, गिव मी 2 to 3 minutes में अभी आपके क्वेश्चन का भी आंसर करता हूं. ठीक है, लेट मी वाइंड अप द
Okay,
लेक्चर
sir.
फर्स्ट. ऑलराइट, सो Zainab's asking for the recording, and I'll discuss the recording at the end of the lecture. Do remind me. Okay? If I forget it by the end of the lecture, do remind me on WhatsApp. Okay? All right. So coming back to the point, हम वहीं पे आते हैं जहाँ से हम कर रहे थे काम. Okay. So let me clear all the annotations. Let me bring it up to the mouse. Okay. So we were discussing about this structure. Now let's make a branch to this structure. This is a straight chain structure. It has no branches. What if there is a carbon atom present at the bottom of this structure? What now? The entire structure is changed, right?
Yes, sir.
Now, what I'm going to do is that I'm going to change the structure a little bit. Now, previously, if I don't draw this structure, then it would be propane, right? If I erase this, let me erase this. What is this? This is propane. 3 carbon atoms, prop, the thing that I started with, and single bonds ane, hence propane, right? So what if I change the structure a little bit and there is a carbon atom at the bottom? So the structure is like this. What then? So let me clarify. Where are the pens? Now this part of the structure is actually what? That is, and please don't mind my writing. That is, wait a second. That is parent chain. Okay. Parent chain. Okay. And this one is then known as branch. Okay. Are we clear? Why are we calling the one on top as parent chain and the one at bottom as branch? The one on top is the straight structure containing more number of carbon atoms, and the one at bottom is the branch. That's how the tree acts. Have you taken a look at a tree carefully from nature's point of view? That larger structures are considered to be the part of trees, and the smaller structures are then considered to be branches. You cannot consider the whole larger structure as a branch and the smaller structure or the smaller growing part to be a tree. We can't do that. That's how we name it. And in chemistry, it's the same as nature's. The bigger parts of the structure are known as the parent chain structures, and the smaller part of the structures, outer structures, are known as branches. Are we clear?
Yes, sir.
Good. Now, how are we going to recognize which part exactly is the structure, is the parent chain, and which part of the structure is the branch? Because the parent chain has specific number of carbon atoms, and for those, we had the rules. Now, let's come back to the rules. In fact, we don't have time to come back to the rules. I'll go with the same thing. Let me save this document as nomenclature. Let's save it. We'll use the same document tomorrow. So as the class is about to end, we'll go with the numbering and the rules of nomenclature to recognize what part of the structure is parent chain and what part of structure is branch tomorrow. As far as that part is concerned, I'm going to close the whole thing. As far as the Zenob's question was concerned, just give me a minute. Zenob was actually asking about the recording, and actually what I've been doing recently for A levels, and I'm also planning to do that for C3, is that I'm going to upload all the recordings so far over the internet that I was previously doing to WhatsApp. Now I will do that to YouTube. Now, please open up your chat. Quickly try to copy this link and save it. So far, it only has a couple of video or maybe only one video. But over this weekend, I'll try to upload all the videos of C3 class we've studied so far. Okay? It's open for everyone. You can use it at any time. In this way, if you were absent in one lecture or two or three, okay, you may go back, you may understand it, or you may even use it to prepare your tests. All right, because we are going to go with full book revisions and unlimited numbers of tests in this year. All right, are we all clear?
Yes, sir.
Good,
Yes,
good.
sir.
Have you copied it?
Yes, sir.
Good. Then I'm going to end the class. Take care, class. Allah Hafiz.